Your answer can only ever have I in the end, okay? You can only have numbers and I. You can't have I squared or I cubed or anything like that, okay? So we can switch out our I squared for -1. So when I switch that, I have 5 times -1, and then I still just have this -10i. Then 5 times -1 gives me what, Mia? Yes, I have -5, and then I have the -10i. And then the only thing is, you are always supposed to put the real number in first, like in front, and then the imaginary part second, just like the poster says, just like the slide said. So the A plus BI, so you start with your real number and then you have your imaginary. So we just have to flip them, so we'd have -5 minus 10i would be our answer for this one, okay? So yeah, so when you distribute, you ended up with the I squared. I squared we can switch out for -1. So then we have just a real number, and then real numbers go in the front and imaginaries go second. Okay, so your answer should always look like something like A plus BI, just like the poster. No I squareds, no I cubes, no I anything else, okay? Good? Okay, let's try the second one. All right, so this one I have 7 minus 4i, and then -1 plus 2i. All right, Kaden, go ahead and help me FOIL.
7 times -1
Is gonna be,
-7.
okay, then what?
7 times that 2i,
Which is?
14i.
Okay,
Then, yeah, those two, which would get you 4i.
okay,
And then negative 8i squared.
yep, exactly. Then Kaden, what could I do next?
Combine like terms, you get -7 plus 18i minus 8i squared.
Okay. What could I do after that?
Substitute
Okay, what would I substitute?
I for I squared root of -i.
Yeah, I can switch out my I squared for, well, nope, so we don't want to switch out I for the square root of -1, is that what you said?
Yeah.
We want to switch out I squared for -1. So your answer should have numbers and I. So if you have I, you're good. But if we have I squared, we're not good. So we can switch this out for -1. So I'd have -7 plus 18i minus 8 times -1. So the squareds get switched out. The I, we don't need to switch that out because that's part of the poster, that's part of the complex number, okay? So then from here, Mackenzie, what would I do? Yeah, exactly. I'm gonna have 1 plus 18i. Okay? So even though we had an answer with a number, an I, and an I cubed, once I simplify all of it, I still end up with something where it's just the real number and then the imaginary number. So it's just that complex number that I need. Questions on the second one? How are we all feeling? Do you hate imaginary numbers? Kaden does. I'm sorry, Kaden, you will see them for the rest of the year.
Oh, okay.
They'll be used in almost like every other problem, so. Okay, let's do this last one. So this time I have 6 plus 3i and then 6 minus 3i. All right, let's see. Brayden, go ahead and help me.
FOIL it.
Okay, what would I do?
36.
Okay,
Minus 18.
okay,
Plus 18i.
okay,
Minus 9i squared.
okay. Then what would I have?
36 minus 9i squared. 9i squared.
Yep, the negative 18i and the positive 18i canceled each other. Then Braden, what would I do after this?
Replace the I squared with -1.
Okay,
And that gives you 36 plus 9.
Okay.
Is 45.
which is gonna be 45. Yep, so for this one, I ended up with 45. So it came out to be just a real number, not a complex number, because all my i's ended up canceling it out. Do you guys feel okay multiplying? Caden doesn't, but Caden will come see me during class.
It won't help.
I can give you lots of problems.
It still doesn't make any sense.
Alright, I'll find some resources for you to read up on it, Caden. Alright, complex conjugates. So, in this last example, the one we did right here, 6 plus 3i and 6 minus 3i are what's called complex conjugates because they're in the form of the real numbers are the same, but our imaginary numbers have different signs. So I have a plus bi and then a minus bi. And we use these a lot, actually, like we're using them in calculus right now. So complex conjugates are a handy way to solve a lot of times. So just understanding that you keep the real number the same, and then you just have to change the sign of your imaginary number. So 6 stayed the same and it was still positive 6, and then the 3i switched signs and we had negative 3i. And the reason we do that is gonna be, so it says the product of complex conjugates are always gonna be real numbers. So when you multiply two complex conjugates together, you end up with an answer that's just a real number. You don't have any i's with it, because the i's always cancel each other out, which is gonna be handy when we get into the dividing. Okay, so we'll divide in just a second, and we'll have to know how to do complex conjugates in order to divide, because we need our i's to drop out. So on the bottom down here, I have the number 12 minus 4i. What do we think the complex conjugate of that number is gonna be? Paige, what do you think? Yep, so the real number stays the same and the imaginary is opposite.
12 plus 4i.
Yeah, exactly, it'd be 12 plus 4i. Okay, so if I start with the number 12 minus 4i, it's complex conjugate, the real would stay the same, so I'd have 12. And the negative 4i, the sign's gonna flip, so I'd have plus 4i. And then my other one, I have negative 2 plus 32i. What do I think the complex conjugate of this one will be? Haley, what do you think?
-2 minus 32i.
Yeah, negative 2 minus 32i. Yep, because my real number stayed the same, so negative 2 is still negative 2. And then the 32i became negative 32i. Okay, so you just keep the real the same, change the sign on the imaginary. Okay, so dividing. So it says when we're dividing complex numbers, we're gonna multiply the numerator and the denominator by our complex conjugate of the denominator. Okay, so I'll kind of walk through this first one. So we have 5 plus 3i over 1 minus 2i. So what I need to do is I need to start by figuring out what my complex conjugate of my denominator is. So the 1 minus 2i, what do I think the complex conjugate of that is gonna be? Faith, what do you think?
Plus 2.
Yeah, 1 plus 2i. Yep, because my real number stayed the same, and then my imaginary, the sign's flipped. So I'm gonna multiply both my numerator and my denominator by 1 plus 2i. Okay, so it's just like I'm multiplying by 1, because you can always multiply by 1. So anytime you have the same thing in your numerator and denominator, that would simplify to be 1. So this is totally legal. We can always multiply by 1. Okay, so now what I need to do is I'm gonna need to FOIL both my numerators and FOIL both my denominators. So it's kind of two problems in one. So if I start with my numerators, I have 5 plus 3i, and that's times 1 plus 2i. So let's see. Sorry, there's not that many of you guys in here, so I call on you all a lot. Cooper, go ahead and help me FOIL this.
5
Okay.
plus 10i.
Okay, yep.
And then 3 plus 3i.
Okay.
Plus 6i
6i.
squared.
Yep. So then what can I do, Cooper?
9. So it'd be 5 plus 13i.
Yep.
Plus 6i squared.
Okay. What should I do after that?
Plug negative 1n for I squared.
Okay. So what would I have?
5 plus 13i plus 6.
Will it be positive 6?
Oh, minus 6.
Yep, minus 6. And then I'm gonna get?
Negative 1 plus 13i.
Yep, negative 1 plus 13i. Awesome, thanks Cooper. So our numerator is gonna be negative 1 plus 13i. Okay, so I multiplied that together and I got negative 1 plus 13i. Now we just need to multiply our denominators together. So if I do that, I have 1 minus 2i times 1 plus 2i. So, Mia, will you help me do this one?
1 times 1 is 1.
Okay,
And then 1 times 2i is 2i.
okay,
And then negative 2i times 1 is negative 2i.
perfect.
And then they just cancel out.
Yep, and these will cancel out.
So it would just be 1.
The only thing we forgot, so negative 2i times 2i, that last one would be
Oh, negative 2i
4i.
squared.
So like you said, we canceled them out, so I have 1 minus 4i squared. What can I do with that?
Multiply 4 times negative 1.
Yep, I can switch that out, so. So I have,
1 plus 4.
yep, which is gonna give me,
5.
cool. Yep, so for this one, I end up with just 5. So my denominator is 5. So then the last step is I'm just gonna split them apart, just like on my poster. I have my real number and then my imaginary numbers. So I'm gonna have negative 1/5 plus 13i over 5 would be our answer for that. Okay, because it came out to be a number, it's just a complex number. I have, this is my real part, negative 1/5, and that's my imaginary number is the 13i over 5. Okay, so you can see, even though it ended up like something like this, if we write it in this form right here, it makes a little more sense because you can see it looks like a complex number. We have a real part and we have an imaginary part. Okay? All right, let's see. Let's go ahead and try to get through this very last example so we don't have to do it tomorrow. All right, so I have the square root of 10 for this one divided by the square root of 10 minus I. Where should I start with? Or what should I start with? Rain, what do you think?
Flip the square root of 10 minus I.
Okay, what would it be?
10 plus, the square root of 10 plus I.
Yeah, so I'm gonna multiply by my complex conjugate of my denominator, which Brayden just said is gonna be my square root of 10 plus I over the square root of 10 plus I. Okay, so now we can go ahead and multiply our numerators together. So I have the square root of 10 times the square root of 10 plus I. So in this case, I don't actually have to FOIL, it's just one of those that I'm gonna distribute. So Faith, go ahead and help me. So square root of 10 times square root of 10, what do you think that's gonna be?
Cancels out.
The square roots cancel out, yep. So I'd be left with just 10. And then square root of 10 times I would just be, we can just say square root of 10i. We can't really simplify any farther than that one. Yep, so whenever you multiply two square roots of the same number together, it's basically, because you're multiplying it twice, it's like you're taking the square root of 10 squared, because square root of 10 times square root of 10 is the same as this. So you can always remember that like your square root and your squared would cancel. So your two square roots just cancel each other. So you always just have the number left. Okay, so we have 10 plus the square root of 10i. I'm sorry. So a 10 plus the square root of 10i. That's our numerator. Then our denominator, we are going to have to FOIL this one. So I have the square root of 10 minus I times the square root of 10 plus I. Okay, so let's see. Haley Berry, will you help me?
Yep, so it cancels, right?
Yep, so those would just be 10, yep.
So then, would it be square root of 10i?
Yep, square root of 10i.
And then negative 10i?
Negative square root of 10i.
Oh, close, yeah.
Yep. And then the last one.
Or would it just be I?
So negative I times I would be,
Square?
yep, squared.
Okay.
So a negative I squared. So now what happens? What happens with these?
It
Cancels. So I just have 10 minus I squared. Now Haley, what can I substitute for I squared?
it can be negative 1.
Yep, so I'd have 10 minus negative 1, which gives me 10.
I.
So 10, so the minus the negative 1 would be just plus 1, right?
Okay.
Because the minus the negative. So 10 plus 1 gives me,
11.
yep, gives me 11. Cool. So then we know our denominators are going to be 11. So then if I just break it into my real and my imaginary, I have 10 11s plus square root of 10i over 11. Okay, so that would be your answer for that. And that was everything we talked about, guys. So that's everything. You should feel okay. You can start.